Good day, and welcome to the presentation of the new standard for road lighting, the new European standard, EN 13201, published last year in 2015. So, the previous standard was published back on 2003 and included 4 sections. The first one, section 1, was related to the selection of lighting classes. The second one about the performance requirements. The third about how to calculate the performances. And the fourth one, it was related to the methods of measuring lighting performance. It means how to measure the parameters on site at the installation. The new standard was approved recently. It was approved on December 2015 and includes the revision of section 2, 3, and 4 and the introduction of section 5, which is related to the energy assessment, the installation energy assessment, which is quite an interesting new feature that was added to the standard. The first one, the selection of lighting classes, was in practice was not absolutely changed, so it keeps going in absolutely in the same way. Let's analyze now in details the different sections of the new standard. Let's start with the section 2, the redefinition of road classes. Was one of the main activities that was performed on this section of the standard. As we know, the classes, the lighting classes at the previous standard were ME, related to urban or extra-urban roads with mainly motorized traffic where luminance values can be calculated. And this is a main point, because it is the difference characterizing the two classes ME and CE, which was for motorized pedestrian roads where there are zones of conflict or where luminance values cannot be calculated. It means, for example, that at a roundabout, which is a conflict area, it is quite difficult to calculate the luminance in the same way like we calculate on a straight road, which is performed through the ME classes. So also commercial roads, historical city centers, roundabouts, junctions, roads with pedestrians and cyclists, underpasses. These are all classes related to the road where we have vehicles passing by the road, but where the luminance cannot be calculated. These classes, as we said, are classes CE. Then there are 2 sets of other lighting classes, S and A, related always to the old standard, which are classes for areas, mainly for pedestrians or cycling use, residential roads, areas adjacent to the carriageway, such as emergency lanes, parking areas, sidewalks. And the last set is related to additional classes where it is important to calculate the semi-cylindrical or vertical illuminances. That is where recognitions of faces or vertical planes is important. For example, for road crossings or pedestrian crossing, this is these are areas where it is important to know the vertical planes and the vertical illuminances in order to perfectly recognize the pedestrian who is crossing the road, or in case of facial recognition, face recognition for questions of safety. The new standard is changing the classes, mostly the names of the classes, because as we can see in few minutes, practically the values related to any classes keep unchanged. So, for example, the ME classes are now called M classes. The C are called the C classes. The S and A are called P and HS. The ES, EV are called SC and EV. EV is the only class that didn't change absolutely. So it keeps staying absolutely in the same way like before. So let's start with the analysis of the ME classes. As we can see, the ME classes were characterized by three groups of parameters: the ones related to the luminance, the ones related to disability glare, and the one related to the lighting of surroundings, which means luminance and the uniformity parameters, the overall uniformity and the longitudinal uniformity, and disability glare with the TI, with the threshold increment value, and the SR, which is the surrounding ratio, with the corresponding values we have here. With the new standard, the ME classes, as we said, are now called M1, M2, up to M6, and there is another big difference because the three ME3 classes, which were split into A, B, and C, are now put together into a single M3 class, where the only difference, as we can see here, was the longitudinal uniformity, which is now kept only at 0.6, which is the value in the middle. Also, the same was made for the ME4 classes, which were split into A and B, and now we have a single class with the 0.60 as uniform longitudinal uniformity. Another quite interesting change is related to the wet conditions. So when the asphalt is wet, in the previous standard, there was a proper and single matrix related to such a condition. But now it was put together, and the only difference is that it was defined overall uniformity for the wet conditions. But all the other parameters can be applied absolutely in the same way. So we will have M1 class, and in function of wet or dry conditions, we are going to apply 0.40 for dry conditions and 0.15 for the wet conditions. All the other values are kept absolutely the same. Let's come now to the disability glare. Also here, there was no change in the values. The only change was related to the definition of the parameter, whose name now is FTI in place of TI, like it was before. The same change was also applied to another parameter, which is the maintenance factor, which previously was commonly called M, and now it is called F of M. Absolutely in the same way like in this case. Another big change that was introduced is related to the surrounding ratio. Now there is no more the surrounding ratio, which was replaced by the EIR, which is the edge illuminance ratio, which is a new parameter that was introduced in order to give a better idea of how the surrounding areas, the adjacent areas, are lighted in function of the carriageway lighting. So the SR, which had these values, were replaced by the EIR values. And we will come back to these parameters in a short time. So at the end, what is the new standard introducing? It is introducing an harmonization of the new standard in function as much as possible of the national standards of the different European countries. It is absolutely impossible to cover all the differences that we have now in Europe, but at least it is an attempt to come to a common point related to the different standards of the different nations. And a line at the end with the CIE 115-2010 edition 2. Let's come to the second set of, to the second lighting class, which is the CE, that is now called C. So in practice, as we can see here, there is absolutely no difference compared to the previous one. So the previous one was based on luminance of the carriageway. As we said, it is difficult to calculate luminance in these areas because are conflict areas. So we have the maintained average illuminance value, and these are the values. As you can see, there is no change in the values, also for the overall uniformity, which is kept absolutely the same. But the big difference, we can say, is the introduction of the TI calculation. But how can we calculate the TI if we cannot calculate the luminance? So the standard is helping us, saying that it is possible to calculate luminance, but not being possible to calculate it as we calculate for a straight road and through the R tables. It is possible now to calculate luminance using for the area the Lambert law, which means a complete diffuse reflection of the surfaces. It is not probably the best solution, but it is the only possible solution because, as you know, it is not possible to place the observer at 60 meters from the conflict areas. Why? Because the observer could lay outside the area of interest or placed in a position where it is a nonsense. Third step, the introduction of the P and the HS classes for pedestrians and cyclists on pedestrian or cycling use areas, or also emergency lanes adjacent to the carriageway. So in place of the previous S and A classes, we have now the P and HS. The values are in practice kept the same like before, but also here we have the introduction of the calculation of the TI, the disability glare parameter, which was not available before. Also for the hemispherical illuminance, so the HS classes, we still have the same values. Last set of lighting classes, the SC classes and the EV classes. So as we said, this class didn't have any change, so it remains unchanged, completely unchanged also for the values, and the semi-cylindrical lumens for the HESC classes are kept absolutely the same, only the name was replaced. In place of ES, it was placed SC. So, let's come now to the third section of the standard, to the part 3, which is the one related to the lighting calculations. There was a change introduced for the TI calculation. So as you know, the TI is calculated through this formula, which is 65 by the Wheeling luminance divided by the Li, which is the luminance at the installation, average luminance, initial luminance, elevated at 0.8, where the LV, we can find it through this formula, is calculated as the summation, as the sum of K from 1 to the n luminaires, which means the total number of luminaire which is corresponding to the view of the observers, and in function of how big is the angle of view of sight of the observer, we have two different formulas. Previously, the formula was only this one, so LV, the Veiling luminance, and the luminance corresponding to the single luminaire was calculated through this formula, where this first part is related to the consideration of the age of the driver, of the observer, multiplied by EK, which is the luminance that you find at the eye of the driver, divided by the angle of sight, the sight angle, elevated at square. So this is valid. This is valid only for angles in between 1.5 degrees and 60 degrees. But as we are going to see in few minutes, there is also another big change introduced for the calculation of luminaires placed at a height lower than 2 meters. So in this case, the sight angle was not this one. It is much reduced because the luminaires are placed very close to the eyes of the observer. So it was not possible to calculate the LVK. So the new standard is introducing a revision to the formula, and this is the new formula. Let's say that in the old CIE 30, which is the first CIE standard introduced many years ago, this part was equal to 10, which is corresponding to the AY of 23. So for a driver of 23 years old. Let's come now to another big change that was introduced for the M classes, which is related to the surrounding ratio. As you know, the surrounding ratio was based on the ratio in between the sum of the horizontal illuminance, average horizontal illuminance about the strip 1, which is this one out of the carriageway, and strip 4, which is on the other side of the carriageway, divided by always the average horizontal illuminance of strip 2 and strip 3, which means that we summed and we put them into a ratio, coming to the SR value. But through this parameter, it was not possible to have a clear idea about where was not the system working. It means that if we give a single SR related to the whole carriageway, we don't have an idea if this side is not lighted in a proper way compared to the other. So because it is an average. The new parameter is now managed in a different way. So it is managed, the concept, in a different way. The edge illuminance ratio, also called REI, is the minimum values of the two ratios. The first one is always the ratio in between the horizontal illuminance of strip 1, which is this one, related to the adjacent strip inside the carriageway. And on the other side, we have strip 4 on strip 3, average illuminance of the other two strips. So in this case, we have to show at our reports after the calculation the minimum value coming out from the calculation. So you can understand that in this case it is possible to have a clear idea where we have the worst condition, and in case we are below, we can apply the changes to our installation. So as we were saying, the new standard is introducing the calculation of the TI, also considering luminaires placed at a height lower than 2 meters. But in order to run the calculation in this way, and also to consider this situation, it is necessary to expand the metrics of the R tables. So the white ones are the values corresponding to the old R tables. So the famous C1, C2, or the old R1 up to R4, for example. In this case, in order to allow the calculation of these conditions, of these situations, we have to expand the matrix up to the epsilon, tangent of epsilon, up to 20 degrees. Sorry, not 20 degrees, tangent of epsilon up to 20. It means that all these values must be added in order to run the calculation. The new standard is also carrying a new, completely new definition of the decimal you have to consider about the different, related to the different parameters. I have to say that previously, following also the experience that we had over here in Italy, it was quite confusing sometimes comparing different results coming from, let's say, results about the same parameters but related to different softwares. So, for example, some softwares were considering for example, the average luminance with a single decimal, and others with 2 decimals. So, in some cases, when we were at the border of the, let's say, the limits about the values, with the roundings, the one calculation was in, but the same calculation performed with a different software, it was out. So it was quite messy, quite a mess for the designers to understand which was good and which was not good. So in this case, the standard is coming and helping us to define exactly how many decimals we have to consider for the different parameters. So in this case, we can see that the average luminance must consider 2 decimals. Also for the overall uniformity and the longitudinal uniformity, while for the threshold increment, we have to consider no decimal, while for the edge luminance ratio, we have to consider 2 decimals. And another interesting consideration was made on the horizontal luminance. So if we have values below 10, we have to consider 2 decimals. It's then 1 decimal in between 10 to 20, and above 20, no decimal. Last part of the section defining the calculation of the different parameters was introduced about the flowchart of different parameter calculations. So it means that previously was not defined how to calculate exactly through a flowchart the different parameters, which is now defined through the standard. And also, another big point is that the standard is now carrying clear tables with different parameters where all the different parameters are clearly defined, and also with the symbol related to the parameter is clearly defined. This is in order to help the developers of software of the different software to keep the same parameters, so that at the end the final result will be a calculation and, for example, a printout considering through different software, considering the same parameters, and it will be much easier to compare one with the other. Let's come now to section 4, where I'd like to point out that 2 main points are now characterizing this new standard, this new section. The concept of approximate value and the field measurement uncertainty evaluation. So in the previous standard, it was defined that the calculation was based of a single parameter, was exactly define a perfect value. So there was no limit. So there was no uncertainty defined about the parameter. The parameter should have been, for example, 50, and it was a single value. The concept that was now introduced is that whenever we run a field measurement, we don't have to consider exactly a value, but we have to consider an area of probability. So we have to give an uncertainty evaluation. And in order to carry this uncertainty evaluation, we have to consider different groups of components characterizing the definition of the uncertainty. In here, we have summarized some of them, the main ones. So, for example, the metrological characteristics of the measurement system. So the luminance meter or the lux meter that you're using to perform your measurements. And in case the influence of the measurement procedure. Second step is the influence of the nominal characteristics and layout of the road lighting installation being measured. So for example, when you run a calculation, you probably are considering the luminaire placed at a certain position, but when you come to the road, this position couldn't be probably respected. So there is an uncertainty also introduced in this evaluation that you have to consider whenever you perform your measurements on the road. And last but not least, the influence of the instantaneous characteristics of the road lighting installation being measured, and of the weather and environmental conditions. So, if you are measuring the performance of the installation when it is minus 20, probably it will affect, in a way, the luminaire flux, for example, because we are working at a very low condition, or when it is too windy. So the standard is saying that you have to perform the measurements in the best weather condition possible. There is a fourth set of parameters, the ones related to the source, the electrical source parameters. So for example, the measurements of the voltage supplied to the installation. The standard is saying that even considering these three sets of groups of components, it is enough. And for the time being, the source parameters are not considered, shouldn't be considered for the calculation of the uncertainty of the measurement. We may agree or not, but this is what the standard is saying. Let's come now to the brand new section of the new standard. So the one related to the energy performance evaluation, assessment. This assessment is introducing two main parameters. We're going to see that there are other two interesting parameters, but not so important like these two. So the first one is the DP or PDI, the power density indicator, and the second one is the DE, the AECI, annual energy consumption indicator. These parameters must be applied for all traffic areas covered by the series of classes M, C, and P. So the classes for the road, for the carriageway, and for the conflict areas, and for the P classes. And it is interesting to say that these parameters must be supplied together, must be presented together, and you cannot supply a single one without considering the other one. Let's come now to see how these parameters are calculated. So this is the formula about the DP parameter, so the power density indicator, which is the ratio of the system power divided by the sum of the at the end the flux, because it's an illuminance multiplied by an area. So the luminance of the I area, average illuminance of the I area, So it is saying that if we have a road characterized by different areas, so an area of an M area, for example, then a C area for the conflict area, and then a P area, we have to consider the luminance and the area of any of these areas and sum them together. So the system power divided by the sum of the different fluxes on the different areas. This is the dimension of the unit of the dP. So it is a watt on lux by square meters. Let's say something about the P. So the P is the, as we said, the system power, which is the sum of the different, let's say, the different profiles. So it means that we can let our system work through different conditions. We are going to see how in a short time. And this power, it is the system power. So it is considering the power related to the luminaires, considering not only what is absorbed by the luminaires, from the point of view of the lighting optical part, but also from the point of view of the drivers, the ballast, etc., the regulators included at the single luminaire, plus an additional power, which is the power related to the regulators that you can install at the beginning of the line, at the supply source. For example, whenever you govern, whenever you manage your system through a main regulator, which is placed in a cabin far away from the area of interest. So, and this is quite an interesting concept that was introduced in order to consider the complete power and not only the power related to the single luminaires. So in this case, this standard, it is introducing the concept of the regulation of light managed through different systems. Let's come now to the second parameter. So we set the annual energy consumption indicator, DE, which is the ratio of the ratio of the sum of the different power by time, which means the energy of any different profile divided by the area of interest. So the unit is watt per hour, which is energy, divided by square meter, which is at the end it's the concept of the energy per unit of area during the year, because in this case we have to consider that these parameters, it is an annual energy consumption indicator. So our consideration must be performed considering the all profiles that we have during the year. So for example, let's say, and we come to the next slide. As you can see here, we have three different profiles. The first one is characterized by a constant power all over the turn on of the system. So it means that in between 6 p.m. up to the day after 6 a.m., we have the system work at 100% of the power. In the second case, we have a B power profile. So it means that for the first 5 hours, we work at 100%, and then we reduce power during night at 50%, and then come back to 100% from 4 o'clock in the morning up to 6 o'clock. The third case is related to the so-called 3-power detector-driven operational profile. So it means that in this case, we have some sensors of presence. So for example, we have sensors viewing if some vehicles are passing, and whenever a vehicle is passing through the road, the system will turn on or put up the power level and come back to the lower level whenever there is no vehicle passing. So in this case, we have a system which is also helping to reduce the energy consumption. It is quite a more complex system, but at the end we can find that the results are quite interesting in order to save energy. Last point related to the energy performance indicators and parameters. These two parameters were introduced in order to help the designer to find the best solution possible for the installation under consideration, and especially the Q-inst, the installation lighting factor. It is a factor saying that, first of all, it is the ratio in between the luminance, the average luminance on the Q0, so the luminance factor related to the R table used for the calculation, multiplied by the average luminance of the area under consideration. It means that if we keep, for example, the illuminance at the same level, we can improve luminance if we improve also the Q0. So, for example, if we have an asphalt, in place of being completely black, we use a gray, for example, asphalt, which has a higher Q0, for sure we're going to have a better L average. So, the average luminance. So, at the end, we can say that the Q-inst, it is good if we are above 1. And in this case, we can get good results. So it means that it is helping the designer in order to find the best possible solution. Few words about the installation luminous efficacy. It is also another parameter which is quite interesting in order to achieve the best result possible in our installation. Okay, I thank you for this presentation, this introduction. We can come now to see how we solved and we applied the new standard to our software. So in this case, we have a single road which was already calculated previously. We have a single road based on 2 carriageways, as you can see here, and a single line of high mast, characterized by 2 lines of luminaires at the central median. The calculation was already performed, and if we come to the visualization of the results, oh, sorry, I have to calculate again. In a few seconds, we are going to have the results. We can see that okay, these are the results. So the carriageway is characterized by 2. The road is characterized by 2 carriageways with different directions. Here we have the standard that we applied to the 2015, and here we have the evaluation of the different parameters in function of the class that we selected for the road. And in this case, we have dry conditions. If we select wet conditions, we are going to have obviously different values, but only related a different value, which is related to the UL. As we saw, it is 0.15 whenever we have a wet condition. In here, we have the results, the summary results of the 2 carriageways, and in here, we have the evaluation of the energy performance indicators. As you can see here, we have 2 different set of values. The first one is related to the system working at 100% power all over the switch on period. So we can define the total hours and automatically the program, in function of the operational power, which is the one related to the luminaire, and the additional power, which is the one related to the regulator, as we said, placed far away from the area of interest, we have a total power density indicator, dP, of 0017 related to the installation under consideration, and an annual energy consumption indicator, DE, of 602. But down here, we have also the opportunity to introduce the different profiles. As you can see here, from October to March, we have a total of 180 days, and we can define different profiles in function of the different period of the day. So it means that in this case, starting at 6 p.m. up to midnight, we have a total of 6 hours. We consider, in this case, a detection probability 100%. It means that we don't have any detection system available, and a total power of 100%. So for 6 hours, we work at 100% of our power and 100% of the flux. And this is the dP that the power density indicator coming out from the calculation. From midnight up to 6 a.m., we also have 6 hours, and we work at 50%. And this is the main point. Probably we don't have the same reduction. So if we reduce 50% the power, it is not said that we reduce 50% the flux. So it depends by different situations, by different means used for the regulation of the system. So in this case, let's say that we have a flux reduction of 40%, down to 40%. So it means that our luminary is working at the 40% of the total flux. And we come to a dP of 0021. From 6 to 8 a.m., we have 2 hours, and we come back to let the system work 100% of the total power. We change the period of the year, and from March to October, we let the system work from 8 o'clock in the night, 8 o'clock p.m., up to 11 o'clock, which is for a total of 3 hours, 100%. And then from 11 o'clock down to 6 o'clock, we have the system working at 50%, including also a detection system, which means that in case of vehicle passing, the system will recognize that the vehicle is passing, and it will drop up the system to 50%, because in here we are saying that the system, whenever there is no vehicle passing, the power is reduced to 10%. And in case the flux is reduced to 5% of the total flux available. So it means that whenever a vehicle is detected passing on the road, we have the system going up to 50%. And this is a probability, so it means that for 50% of the period that we are considering, so 7 hours, so it means that for 3.5 hours, 3.5 hours, we have the system working at 50%. And for the other 50%, we have the system working at 10% of the total power. So, as you can see here, it is possible also to add other periods of the year and other time slot of the day. But it is also possible to save the configuration. So let's come now to define a new installation. Okay, I save this installation, and I come to a new installation. So let's define a very simple road based on a single carriageway. The observer age, we keep it at 23 years old. We apply the standard, the new standard. This is the road. Let's say that we have a width of 7 meters for a total of 2 lanes. The lighting class, we select M5 C2 for the R table. Next, okay, in here we can input the luminaire, so we can open an external folder and drag and drop the luminaire inside here, or if the luminaire it is available through the local database, we can simply drag and drop the image from the database into here. So if also the image of the luminaire is available, we can drag and drop the image into here. Once we have finished, this is, okay, let's define the other parameters related to the installation. So we place one row on the right, and the luminance related to the edge of the road, let's say that we have 0.5. The pole setback is also 0.5. The arm is, so we use a post-stop installation. The mounting height 9, and the spacing distance we go down to 30 meters. The tilting angle, we leave it as 0. For example, here in Milano, it is not allowed to install luminaires with a tilting angle different from 0. So all the luminaires must be installed with the glass. So because we have a lighting pollution law which is saying that all the luminaires must be placed with a flat glass and with the glass placed completely horizontally. So let's leave it at 0. And once we have defined all the parameters, we finished. This is our road. If you want to have a view of the photometry volume of the single luminaire, we select View Photometry Solid, and from here we can run the calculation. So the calculation in function of the area under consideration is automatically set by the program. So once we have finished, we have the values related to the and the comparison of the values through the standard. So we see here that everything is perfectly following the standard, and we can note the energy performance indicator. So the system, the program, is proposing the operational power which is brought from the luminaires. We may add the additional power to 5, so automatically the program is changing the annual energy consumption indicator. It is not changing the power density indicator. And the annual operating hour, it is by default set to 4,000 hours. But let's say now that we want to add a regulator and we want to define different profiles. We can do that opening a previous defined profile. So let's say that we select this one. It is automatically loaded. So you can create different profiles in function of the different uses, for example, related to the different installations. So automatically the system, in function of the different profiles, it is proposing you the annual energy consumption indicator related to the profile under consideration. So in this case, we have to review a little bit the values, because we have considering the different profiles, we have a value which is above this value. But let's say this is the concept. Let's delete now. If we want to define a new set of profiles, we can do in this way, head to the bottom. So we define a period. We say that it is in between March and October. The time slot is in between, we send 20 up to 23, which is corresponding to 3 hours. The detection probability, we leave it as it is, and we leave it at 100%. Then we select, if we want to add a new period, we select this one and then press add to the bottom. So a new period will be defined. So October, March, and now we define the time slot in between. We said 18 up to 24. It is a total of 6 hours. And we let the system work 100%. So if we select this one and we press add to the bottom, a new time slot will be added. So we say that from midnight. So from midnight up to 6 o'clock in the morning, we have a total of 6 hours, and we let the system work for at 50% of the total power for 54% of the total flux, 55% of the total flux. We had another one. So from 6 o'clock, I have to add it, 6 o'clock up to 8 o'clock, we have a total of 2 hours, and we let the system work at 100% of the power. So back to the initial situation. So step by step, we can define the different profiles, and if we want, we can save the profile, and we call it profile 24. That's it. So I thank you for participating to our presentation. Now it is time for questions.